What happens when an aircraft engine tears itself away from the wing? And how could something like this even happen in modern aviation? In November 2025, a McDonnell Douglas MD-11F, owned by UPS Airlines, crashed just 37 seconds after taking off from Louisville. So, what went wrong that day? Today, we're breaking down the UPS Flight 2976 crash, step by step. We'll uncover why the engine detached, why the systems failed to respond, and why this accident became one of the most significant turning points in modern aviation safety. November 4th, 2025. Louisville Muhammad Ali International Airport, one of UPS's main global hubs. Flight 2976 was scheduled to fly from Louisville to Honolulu, a routine overnight cargo mission. On board were 3 crew members: the captain, first officer, and relief pilot. The aircraft was fully fueled for an 8.5-hour flight. The weather was clear, visibility perfect. Pre-flight checks showed no issues. Engine parameters normal, no faults on the ICAS display. In every sense, the aircraft was ready to fly. But just moments later, aviation would witness one of its rarest mechanical failures: an engine physically breaking off the wing. At 17:15, the tower cleared the flight for takeoff. The aircraft accelerated down runway 35L. Rotation occurred at about 158 knots. The wheels left the ground. 37 seconds later, a warning tone in the cockpit. According to the black box, it was an engine fire alarm. Witnesses outside saw a massive fireball erupt from the left wing. Seconds later, the engine detached completely. The pylon attach fittings, the components connecting the engine to the wing, likely fractured due to metal fatigue. When the engine broke away, it tore through the fuel lines, intensifying the fire. The pilots began the engine fire procedure, but nothing happened, because the engine was gone. The sensors, valves, and electrical systems that controlled it had all been severed. The MD-11 rolled sharply to the left. The captain tried to level the aircraft, but the burning wing had lost both lift and balance. Within seconds, the jet entered an uncontrollable descent. At just under a minute after takeoff, it slammed into an industrial area east of Louisville. The explosion ignited a massive fireball. All 3 crew members and 11 people on the ground were killed. The inferno was so intense that firefighters battled the flames for hours. In crashes like this, survivability is almost zero. The fuel detonation wipes out everything in seconds. But the question remains, why did the engine break off? And how could no system detect it in time? The MD-11's engines are mounted to the wing by pylons, designed to handle immense forces and built on a fail-safe concept. If one attachment fails, another carries the load. The system's weakness? Metal fatigue. Most MD-11s are over 30 years old. Over time, microscopic cracks form in the metal. They're usually caught during inspections, but not always. The NTSB's preliminary findings showed a crack in the front mount pin of the left engine. During takeoff, torque forces exceeded the weakened joint's limit. The pin fractured, the engine separated, and the fuel line ruptured. Fire, structural collapse, total loss of control. In short, the root cause was likely mechanical fatigue and maintenance oversight. But here's the twist. This pylon mount design had been a known weak spot in MD-11s for years. Boeing had issued prior service bulletins about it. And the black boxes confirmed the timeline second by second. The alarm sounded 37 seconds after takeoff. The crew fought the fire for about 25 seconds. Engine 1 fire, fuel cut. But with the engine gone, the fuel valve never responded. The flight control systems couldn't counter the asymmetrical thrust. The MD-11, especially at low speeds, is notoriously unstable. The roll steepened, A brief aerodynamic stall, and impact followed. At that point, the pilots had virtually no options left. The NTSB, FAA, and Boeing launched a joint investigation. The aircraft's last major maintenance had taken place in San Antonio just weeks earlier. Whether the pylon mounts were properly inspected is still under review. Boeing immediately issued an airworthiness directive grounding all MD-11s for emergency inspection. UPS and FedEx temporarily grounded 55 aircraft from their fleets. The accident effectively accelerated the MD-11's retirement. The aircraft was aging, and maintenance costs were outpacing safety margins. There are 3 lessons from this tragedy. 1. Metal fatigue is the silent killer of aging aircraft. Even when a plane looks fine, microscopic cracks can spell disaster. 2. Sensors can fail with the system they monitor. When the engine detached, its sensors went with it. No warnings could help. This highlighted the need for independent fire detection systems. 3. The MD-11's aerodynamics are unforgiving. Once instability begins, recovery time is brutally short. That's why this aircraft type has been involved in numerous landing and takeoff incidents throughout its career. Ultimately, this wasn't just a maintenance failure. It was a reminder of the limits of aging design. UPS Flight 2976 wasn't just another crash. It was the real-world version of what aviation textbooks once called impossible. An engine separating midair, bypassing hundreds of safety checks. How could it happen? That question still sits on the desks of aerospace engineers today. After the crash, the FAA updated inspection protocols for aging cargo jets. But one question remains. Does an airplane's safety truly decline with age, or only when we stop looking close enough? Perhaps the answer to that question could prevent the next disaster. And maybe one day, those 37 seconds over Louisville will be remembered as the moment aviation safety was rewritten. Because that single chain of events, an engine breaking free, proved that even in the safest era of flight, risk is never zero.